calculate voltage drop, firstly determine the total load current. In this case, it is given as 100 amps. Secondly, determine the circuit resistance. To find this, use the formula R equals 2 times distance divided by conductor area times conductor resistivity, where R represents the circuit resistance in ohms, distance represents the length of the wire run in feet, conductor area represents the cross-sectional area of the wire in circular mils, and conductor resistivity represents the resistance of the wire material in ohms per circular mil foot. For copper wire, the conductor resistivity is approximately 10.4 ohms per circular mil-foot. Thirdly, determine the voltage drop. To do this, use the formula voltage drop equals load current times circuit resistance. Now let's apply these steps using #3 AWG wire. The conductor area for #3 AWG wire is 103.2 circular mils. The circuit resistance is calculated as 2 times 150 divided by 103.2 times 10.4, which equals 2.87 ohms. The voltage drop is then calculated as 100 times 2.87, resulting in 287 volts. Next, let's perform the same calculations using #2 AWG wire. The conductor area for #2 AWG wire is 133.1 circular mils. The circuit resistance is calculated as 2 times 150 divided by 133.1 times 10.4, which equals 2.28 ohms. The voltage drop is then calculated as 100 times 2.28, resulting in 228 volts. In conclusion, the voltage drop for a 150-foot one using #3 AWG wire is 287 volts, which exceeds the acceptable limit of 3% for a 120/240 volt system. 3% of 240 volts is 7.2 volts, and 3% of 120 volts is 3.6 volts. Therefore, #3 AWG wire is not suitable for this application. Using #2 AWG wire will result in a voltage drop of 228 volts, which is within the acceptable limit. For a 120/240 volt service, it's important to consider the voltage drop on both the 120 volt and 240 volt circuits. The formulas remain the same, but you must consider how the load is balanced and distributed between the two legs of the service. If the 100 amp load is balanced evenly between the two 120 volt legs, each leg carries 50 amps. If the load consists of a single 240 volt appliance drawing 100 amps, the entire load flows through both legs. For accurate voltage drop calculation, consider the specific loads connected to each voltage level and calculate the voltage drop separately for each. The example uses a simplified approach, assuming a total load of 100 amps on a single voltage level. In real-world installations, loads are typically distributed differently. Always consult the National Electrical Code, or NEC, and local electrical codes for specific requirements and guidelines on voltage drop and conductor sizing. Additionally, consider consulting with a qualified electrician to ensure safe and compliant electrical installations.